big part of math is matrices. So I'm going to say addition and subtraction, understanding, right? So what is matrix notation? That's one of the big things that we want to ask ourselves if we're learning this new material. What is matrix notation? I'm going to show us, and I'm going to show how to add and subtract matrices. Now, when it comes to multiplying matrices, that's really kind of a linear algebra thing, and I won't get into that. I'm just going to show the most practical way of solving solutions without having to do all that noise. But so what I'll do is we're going to say how to understand how to convert a system of equations into matrix form. And we might also, if there's time, later we can kind of understand what these system of equations are, which you've already covered, but what they mean in matrix form in all this. Right? So first things first, the keystone is for this is that we need to understand standard form.
Standard form. Repeat after me.
You're not going to know standard form, and I wouldn't repeat it until you can see it, or you'll just remember the void. But once I get it, you may. And what standard form is AX plus BY is equal to some constant C. Now, so far we've been given things like, in the previous videos, we've been given things like, let me look at this. Look at some convenient ones. What is this? Let me get a good numerical solution set here. Or coordinate solution 2, 0 seems pretty nice. These two that we had prior, I'm going to take these and we're going to convert these. Since we're already fresh on solving that system, we're going to solve that system using a matrix. And so what we're going to do, let's put this on here. We're going to attempt to first understand what the y coordinate is. So what is y? What does it model? What do mathematicians like to use?
Height.
The height. So f of f and g of x would be like y, correct? So in order to do that, we need to switch our operator notation just to variable notation, respectfully. Right? I'm gonna put a bar so that we're not, so I'm not mixing, I'm not messy with that. Just not a table, just a bar, so we see. Now we need standard form, so we need a number in front of a letter and a number in front of a variable, a number in front of a variable. We need a number. C would be like a number, right? You typically want that to be a number. Otherwise, you've got a function, right? So C, insofar as we're concerned this far, probably needs to just be a number, right? That's in your mind. So what we do is we subtract 3x on both sides over here, and we get standard form, right? Are you sure? And then we do it to the other one. You lead with x, right? Lead with x. Don't be a rebel. Don't be rebel scum. Just lead with x. Keep it simple. If z models height, right? X and y model the bottom. If x models the length, the base, then y models the height. If it's down here, it'd be like, the width and the length, and then z becomes the height. Just use the graphical sense that makes sense. Don't be like x of y. Just use the tradition. It's just going to make things very complicated to understand. Stick to a form. It helps. It really does. Doesn't mean you can't think outside the box and be like, what if z was that way? You sure can. You sure could, but at least you're modeling it the way you can see it. Does that make sense when we're understanding graphs? I need to get that out of the way. I hope that makes common sense. I hope that really drives the key concept there. Are we in standard form at the bottom for this now?
Yes.
Good. So we need to convert this. And remember when we used elimination, right? So the keystone in understanding matrix form is going to be understanding standard form. We need to know standard form. Now here's the cool part, right? Matrices are really just vectors, right? But to get outside of like that being complicated, right? What you do is you label a matrix A and you stack them, right? Stack your equations just like elimination, right? Stack your equations like you did with elimination because they are very similar, the methods. I mean, in terms of the form, not the numerical methods. So let me go ahead and move to another Canva because I'm running out of Canvas.
Why don't you copy and paste this whole slide into that way? Do you know what I mean? I don't know if it's possible if you can do that.
I already did. You're thinking just like me. Good job. So understanding how to convert standard form of equations to matrix form. Okay, so let's go ahead and copy and paste that. Thank you, Padawan. Excellent. Okay, now that's all of this. We can shrink that down. It's so very helpful. Okay. Space. I need to start using more slides. I keep all my lectures on one, and it's just like really messy. So here's what we got going on. What's your question?
Where is this slide to these matrices?
Relevant. So they give you all sorts of forms and formulas, and that's somewhat important, but I like to stack them. But when we say we have a matrix, we have that stack. And the way that works is you stack them up first. So pay close attention to what I'm doing geometric, at least visually here. Okay? And what that is you're just going to stack them quite simply. Negative 3x plus y is equal to minus 6. And then you stack the other one. 2x plus y is equal to 4. And then the way we deal with matrices is we extract the coefficients in front of the letters in their associated columns. So there's an understood 1 here and an understood 1 here, right? Right?
Yep.
Okay. That means you've got a negative 3 and a 1 and a 2 and a 1. We'll call it the matrix M. Hey, baby. Just to make that simple. But most people use the letter A. I don't want to confuse it, so we're just going to leave it like that.
And for matrix, that it makes it more easier.
Right. And then here's the thing. We really have a solution of two equations. So the way we do it, we might put our matrix here, but we also have the vector x and y. But we label that as the vector x. So oftentimes notation for that goes like that. And we set it equal to the solution vector negative 6 and 4, right? So we usually just label that like a C or some sort of letter, right? So this is what's going on. We did, for the purpose of this lecture, convert the system of equations. The coefficient matrix is the one you're going to be solving to find your solutions in x and y. But let me take it a little step further, if I may, in this video. What I'm going to do is I'm going to, remember how I said, in order to understand this at the current level, really what I like to do is I take my matrix M, just like so, negative 3, 2, 1, and 1, and then I take my vector x. What is my vector x? It's equal to the column vector x and y, right? C is equal to negative 6 and 4, right? This is what's going on. So what I do is I kick the ankles from x and y up, right? I boot it to where it's horizontal, and I slap that mentally right there, and I drop my x and y. And look, I've returned right back to the variable part, the variable side of the equation, just like that. Isn't that cool? and it just sweeps down. It multiplies to that, it multiplies to that, it multiplies. It just sticks to everything. It goes down, just like a size or an ionic like some sort of ionic chromatography or adhesive ionic chromatography apparatus in chemistry. The X sticks to what it goes to, and the Y sticks to what it goes. Just like so. Does that make sense visually?
Yes.
Okay. Now I'm having to do like a rough lecture to get you numerically capable for what it is that I want to teach really quickly. And I think it can be done in this way. And what we do, since C's by itself, you just simply go back to what you had before, right? That was just -6. And you just put these equal signs in for giggles, right? You just put them in and it's just like that. Now there's no magic to this, right? It just is, okay? Just accept it for now. Because if I was to teach you matrix multiplication, which we'll do in the next video, I'll explain why I tipped that X and Y, but rest assured to kick the ankle 90 degrees and bam, you're done. X and Y sweeps right on through. It's that easy. So then now we're in matrix form. And if I wrote it all together, right, all together, the way this would look here would be just like this. You'd have 2, 1, 1, X and Y. And that would be, this is how we do it. -6 and 4. Does that make sense so far?
Yes.
So I'm going to pause for now, right? And next time I'll go into something called Gauss-Jordan elimination.
Okay, that sounds like a big name.
And I'll explain a few other things. I'll also explain that when we learn Gauss-Jordan elimination, we don't have to do it fully. We can convert back into the standard forms once we've gotten it simplified using Gauss-Jordan, and we can just do linear decomposition. My mind loves to do that because I'm ADHD. I'm like, oh, I do this half, and I do this, and I'm done. Instead of going all the way. So, or sometimes I get that tunnel vision. It can go either way, but that's how, and next time we're going to do that. Sound good?
All right. Well, thanks a lot.
Anakin, Chancellor Palpatine is evil! From my point of view, the Jedi are evil. Well, then you are lost! This is the end for you, my master. Ninja, vanish!